All right, so we have here an ellipse. These here are the parts of the ellipse. Okay, so an ellipse has two foci or two focal points over here. It also has a vertex on the left, a vertex to the right, major axis, and a minor axis. You may be asked this question. Now, we have drawn ellipses often in our isometric drawings, but here is some construction. How do you construct the ellipse? The first method here is the concentric circles method. So we'll just draw this quickly in Autocad. So concentric circles are circles which have the same center. You follow me on concentric circles? So we draw a circle here, let's say radius 20, and we draw a second circle, radius 30. Concentric circles have what? The same center. You follow me so far? So from here, you are going to divide the major circle into 12 equal parts. So I just divided it into 12. You follow me? Now from here, you do the same thing with the smaller one, div 12. Now to plot the ellipse, which one of these circles do you think is the major one? The bigger or the smaller? The bigger one. That's good. So we draw a vertical line from the major, and we drop a horizontal line from the minor. Where they meet, that's our point. Now let's do the same thing for up here. We drop a vertical line, and then we carry a horizontal line across. Do you see where those lines meet? Yes. So let's put a few points on them. And I'll just change the color. And we are going to use a spline. And this will give us the first curve of the ellipse. I'm just going to do the second half. Remember, from the minor circle, the line goes left to right, and with the major circle, you're going up and down. So I just copy these. Let me see if these meet. Carry this across a little more. Hmm? You saw how I plotted the ellipse just now? Mm. So what method is this? What method is this? Concentric circles. So we're going to take a look now at the other method, which is the rectangular method. So we draw a rectangle for the 80 by 60. And the thing about this method is, now that you have your rectangle, you divide the sides into equal parts. Well, 8 equal parts. So I'll draw a line here. Yes, sir. Okay, no problem. All right, so we are going to divide, and I use these arcs because CXC may show you the actual arcs. You follow me? So the same way that we divided this circle here for the ellipse, I could divide this line into 8 equal parts. But I'm showing you this so that you understand the different arcs that are here. So if you saw them on the exam, you would get it. So the thing here is that we need 8. How many am I at? Remember that you connect the last one, and then we're just going to copy. Yeah, we did. When we divided the line into equal parts. Yeah? So the thing is that you need to watch the recording so that you can go over it. And we are going to do the same thing for the upright. Let's take a look back at the text so we can follow exactly where is it coming from. What method is this that we just did? All right, and this is the method that we're doing here. Rectangular. All right, so how many divisions do we have to make for this side? All right, so same thing again. I would not copy them over here. I would not copy them over here. I would just do it again. Go ahead. How many are we looking for? Good. So remember to carry the last one. Now the thing is that you're going to make sure that they are connected to the correct point, unless it will be off. All right, you understand this so far? You sure? All right, so let's begin to plot then. You gotta pay close attention. We drop a vertical line here. We connect it to this side. And we're gonna pull these first three over here.
Excuse me.
Yeah, no problem.
Good afternoon.
Good afternoon, sir.
And please, young man, live for Jesus. That's all that really matters. If you can deliver me from being a social man on my block in a rough place with talk, because I'm hopeful to come to school and learn there, more what you want to do than no father was choosing to do in kind of school and do this school and learn. Okay.
All right, so make sure you come to school and do your schoolwork. And from here, 1, 2, 3, 4, 5, 6, 7, 8. We made a mistake with this one because we sprayed 9 arcs. So that's a problem that we're gonna have with this one here. Let me just fix that before we go ahead. So that's an easy fix, but the problem will be if you did not pick up on it. You may cut off the low piece. You could leave it because it's just construction. What the focus here will be on is the actual drawing, the final drawing. So if you left that error, you will lose a lot of marks. So 1, 2, 3, 4, the fourth line is the line that we're going to carry up. And then we just pull our points across. And we do the same thing for the next side. You following still? Yes, or we lost? And I'm just going to do this bottom corner. Yeah. Yes. Yes. So if you follow it closely, you will see that they are only going to specific points. Pay attention to these yellow lines that I'm going to do. And the reason for this is that I need this point over here. So I need the points to be transferred to this right side. You understanding this clearly or no? All right, so I'm just going to trim it. And I will just use these to finish off this plot here at the bottom. All right, so we're going to plot the bottom half of this ellipse. You ready? You paying attention? So I use my spline fit, and you're just pulling it through the particular points. Now, if we would like another video where we go through each of these points specifically, we can do that. But at the end of it, you press enter, and I'm just going to change this to red. You see that ellipse there? You see the curve? So you will repeat it above to get your top half done. I'll actually turn off the construction so we can see the curve. See that? So if I wanted the video to go on to finish it, I would transfer these lines here to the top so that I can plot the rest. But I only plotted the bottom. And for this is the ellipse using which method? What method is this? Rectangular. So we have another method called the Trammell method. The Trammell method is where you have the major axis and the minor axis. They are put on a piece of paper. And you will use the piece of paper to plot the ellipse by moving it around. CXC can give you a picture of this and ask you, what method is it? Is this rectangular? What method is it? Trammell. Okay? And the last thing here that we're going to look at, it came a long way. But this last thing here is to construct a normal and a tangent to the ellipse. So remember, we looked at the parts of the ellipse earlier. Pay attention. What are these 2 points here called? The foci, right? CXC can give you a question showing you this, and they can ask you what they're called. But this method, you find your focal point, and then you connect them to a point on the curve of the ellipse, and you construct a 90 for your tangent. You follow me so far? So here is, well, we could do it, but I will show you the question first, and I think we will pause there. Adjustable 125. So you see that is here? The drawing above illustrates the proper method of doing what? So take a look at the questions that they have. Constructing an ellipse with a trammel. Is this a trammel? Is this the construct of hyperbola as a colet section? Is it finding the foci, the normal, and tangent? Or is it finding the focus of a parabola? This is a parabola? This is a hyperbola? Is this the trammel method? So you're going to check back here. Because if you don't know the trammel method, this is the trammel method. What method is this? What you call it, Trey? It begins with R. And what method is this? Yeah. This method here is what? Conic sections. The concentric circles method.